active for me?
Yeah, because I don't want to hear you scream.
So, again, we talked about the order of operations. Now, remember, this is the thing about math. What's true about math? It carries on over and over and over again, right? So, just because we're done with one section, we can't just forget about it. We have to remember that we're going to use that section over and over again. Like I said, the order of operations, you will honestly use the rest of your mathematical lives. So, you're going to use it a lot. So we go back and we talk about expressions a little bit more. What was an expression? Doesn't have an equal sign. Exactly right. Exactly right. So we're continuing to talk about that. But today we're going to focus in on variables. So this is kind of what makes or separates algebra from what you've been doing in math for so long, right? Because up until now, probably, you've never had a letter in math, have you? Maybe, but not really. Okay? So, what's a variable? What does that mean? Anybody heard the word variable?
It's like a letter in a problem.
Right. So a variable is a letter or a symbol that represents a number. Now, what do I mean by a symbol? Anybody know of a possible symbol that would be used that is shown as a number? Do any of you have old enough brothers and sisters that are in college yet?
I don't know what he does though.
Well, Josie just went, right?
Yeah.
But nobody else got an older brother or sister yet? All right, that's fine. So, have you ever heard of, when you watch like movies and stuff, sororities and fraternities? What do you always see on the side of their buildings? How do you name a sorority or a fraternity? You know that?
Their logo?
Their logo or their letters, right? Well, their letters are the Greek alphabet, but a lot of the times those are symbols. So when we say symbols, we would use maybe something like this. Okay? We might use a circle with a little squiggly in the middle. This is theta. Okay? Theta is one of the Greek letters, but you'll see theta a lot in math. Okay? When we talk about a letter, though, we're just talking about a lowercase letter. It could be an uppercase letter. But what we want to talk about is to make sure that you be careful with certain letters. So again, we talked about X yesterday. Why don't we want to use X in multiplication anymore? Bless you. Because it's going to look like our X as a letter, right? So when you see X from now on, it's probably a variable instead of multiplication. You want to be kind of careful with T's, right? Because T's can turn into what? Plus signs, right? So a lot of times, if I'm going to use a lowercase t, I'm going to put a little tail on the bottom. But I'm really going to probably try to avoid that if I'm writing it. Another one that I'm going to avoid a lot is a B. Because how some of you write your B's might turn into a what? A 6 really easily, right? Now, if I type this out on the computer, it's easy for you to see if it's a B or not, right? But I'm going to avoid using that when I'm writing it. And then I think we talked about Z's yesterday, or the day before too. I'm always going to put a little slash on my Z's so they don't look like 2's. Okay? So, I can use anything that I want, though. It doesn't matter. All right? Okay with all that? So then we talk about algebraic expressions again. And so we're just going to have a problem again, as Jacob said earlier, without an equal sign. Okay? But we're going to these would be variables that are separated by operators. What are my operators again? We talked about this the other day. What is an operator? What symbol is an operator?
Number?
Close. I'm going to have numbers in these maybe, and how would I separate my numbers? By a what? Maybe a slash, so division. What else?
Like multiplication.
Like multiplication. So I'm going to have some kind of addition, subtraction, multiplication, or division, right? Those are operators. So we kind of talked about some of this the other day. But here are examples up here. You want to see up here of expressions, right? X plus 2. Right? We separated it with an operator. 6m. We talked about many variations of multiplication now, right? What were other ways of showing multiplication? Besides my x?
Dots.
A dot. What else? Parentheses.
A letter by a number.
Yeah, a letter by a number, right? 6m. Or, if you notice the bottom one, we can have two letters next to each other. mn. And also, but we said we kind of want to avoid that if we were going to have two numbers, right? If we wanted to say 4 times 3, we're not just going to write 4, 3. Because then it looks like 43 instead of 12 for that we want. Okay? And then, can I solve this problem right here? Can I solve x plus 2 as it's written right now?
No.
No, why?
Because we need that second number.
Okay, I need to know what x is, right? So the only way that I can solve these expressions right now is if the directions tells me what x, m, and n are. And then I would go ahead and simplify. Again, do you understand what I mean by simplify? What does simplify mean?
Find the answer.
Find the answer, or make it as small as I possibly can if I can't find the answer, right? So reducing is another way of saying simplify, all right? We already talked about that a lot. So let's look at some of this. So again, we're going to look at some examples of this to see if we can solve expressions. So again, this is just kind of carrying over from what we had yesterday, but now we're going to introduce variables and we're going to introduce substituting into those variables. So we get x minus y plus 6. Again, now, if this was the only thing that was given to you in the problem, can I do anything to this problem? No. If they don't tell me what x and y are in the directions, and they give me this problem right here as the problem, this is also my answer. Okay? That's okay. Sometimes you might have variables in your answer. That's okay. But in this case, they actually tell us. So we want to solve if x is equal to 27 and y is equal to 12. So now all we're going to do is substitute what they tell us into the problem. What does substitute mean? Switch out is a good one, right? So if you're playing basketball and you substitute for somebody, if Nathan comes in for me, he takes my spot, right? So basically, 27 is going to substitute in for the x over here. He's coming into the game. So we're going to put it in there and rewrite the whole problem. Again, make sure you show your work. All right? So I rewrite 27 minus, what's y now? 12 plus 6. Now we're right back to what we did yesterday in the order of operations, right? Where do I start?
Left to right.
Left to right, Alexander? Left to right. You can't just, hey, I like addition better than subtraction. Because if I like addition better than subtraction, I screw up the answer, don't I? So, what do we get? 27 minus 12?
15.
15 plus 6. 21. Let's see if Alex would have got the same answer, right? He likes addition, so he's going to say, I'm doing this first. 12 plus 6?
18.
27 minus 18?
9.
Yeah, big difference, right? So you can't just go with your gut feeling of, I like addition, I'm going to start there. Okay? Next one. 5. Z plus parentheses x plus 4y parentheses minus 15. And the directions tell me that x is equal to 3, y is equal to 4, and z is equal to 7. Want to try this one on your own?
Yeah.
All right, go for it. See what you get. So again, take your time, write down all the steps, put things into the problem first, and then try to do the problem. It's not a bad thing to show work. So again, that's what I'm going to do first. Just rewrote the problem, but I substituted my new players into the game. Now I'm going to go back. Now here's where I can kind of bend the rules a little bit. Now if you're not a rule bender, that's fine. But I know that I have to come over here and start inside parentheses. But if I do this part of the problem right here, does it really affect any other part of the problem except what I'm going to add? No, so even though that I know I have to start over here in these parentheses, I can simplify this one first too if I wanted to. Okay? So I'm kind of just trying to speed up the process. But now I'm going to start way here on the inside. I have to do that 16 first. Now what? Agreed? Now Alexander's in good shape because he gets to add first no matter what, right? 35 plus 19. 54? 54 minus 15?
39.
How'd we do? Alex? What'd you do this time?
Wouldn't there have to be brackets in?
Where, buddy? You could have put way up here.
Yeah.
You could have put brackets around them.
Does it matter?
Nope. Nope. I understand what you're saying. Shall we do one more? 5a minus b minus c if a equals 5, b equals 12, and c equals 4. So try her again. So again, take your time. 5a really means I'm multiplying. Minus. So again, I'm going to kind of bend the rules here. I'm going to do two things at one time because here, I should go inside here, but this multiplication isn't going to really make a difference if I do it now or later. So if you're a rule follower, you would have said 5 times 5 minus 8, and then 25 minus 8. I just did them all at one time. Okay? And then 25 minus 8 is,
17.
how do we do? We're on fire, huh? Perfect. So the last thing, basically, is exactly what we did yesterday with the verbal phrases again, okay? Except now there's going to be a little bit bigger sentence to actually go through. Okay, so you got to kind of go a little slower to figure all these out. But remember all those words that we talked about, right? What were the words for addition? What were the words for subtraction, multiplication, and division? Remember, division kind of gets short in the stick because we use all the words with everything else, so it doesn't really have a whole lot. But what's my answer for addition?
Sum.
For subtraction? The difference, multiplication, product, and division.
Quotient.
The quotient. Okay? So, here we go. 35 more than the number of tickets. What does that mean? 35 more than the number of tickets. What would you say? What's more than mean? Plus. So 35 plus the number of tickets. How do I say the number of tickets? So what's the difference between today's verbals and yesterday's? Now you have to include a variable. Okay? So when they say a random number of tickets, that tells me it's my variable. So again, do I want to be specific and say, well, because they're talking about tickets, I'm going to use a lowercase t? I could. Do I want to just be generic and use x every single time? I could do that. So if you're helping each other out or you're checking each other's work with each other, and Alex has 35 plus t, but Carson has 35 plus w, are they wrong? No. They just use a different variable. So don't freak out if you're checking it with somebody and they have a different thing. All right? So here's, are we okay with that one? The difference of 6 times a number and 10. So now we got a combo of two things, right? The difference means what? Subtract. I got to have a minus sign in there. Of 6 times a number. How do I write 6 times a number?
6 times x.
6 times x, right? I make up that variable again. So I have 6 times x and 10. But what does that and 10 mean? Okay, so here's where it gets a little confusing, right? And usually means addition. You're exactly right. But in this case, they said at the beginning the difference of 6 times the number and 10. So that and is actually linking those two things to what? To the difference part or the subtraction. So even though they threw in that word and, we got to kind of throw that out thinking addition and put it back to the subtraction part. So you're exactly right, but in all actuality, you're wrong, right? So we should have wrote what? 6x, and then what? Minus 10, even though that it says and. So we get 6x minus 10. Okay? The next one down. The quotient of a number and 4. How do I write that? The quotient of some number and 4. X divided by 4. Awesome. And then finish the rest. Minus 5. So what do I say?
X.
Minus 5. Now here's the question. Do I need to put parentheses around x minus 4? Could I?
Yeah.
If I put this around that, does it change the answer any? No. Okay. So you can always use parentheses, and you can use parentheses even if you're not talking about multiplication, if you're trying to group things together. So just because you see parentheses, don't always jump to multiplication. This one right here. 7 increased by the quotient of a number and 8. 7 plus
Divided by x.
Okay, so again, be careful here. 7 increased, everybody's good with that, right? That's kind of the easy part. By the quotient of, so this is where when they say quotient, you all thought of division, which is right. But what are we actually dividing in this problem? X and 8. So 7 plus the quotient, that's where I'm going to put that parentheses around there, of x and, what was the number?
8.
8. That makes sense? Okay. So now we have a story problem. Alex likes these ones, so we're going to do extra story problems. Okay? So it says the middle school, that's you guys, we're putting on a play. Oh boy. All right. Hopefully it's not Romeo and Juliet. People kissing all over the place. And all right, adult tickets are $3 and students are $1. Write an expression to find the total amount of money collected. So what would I do? What does that mean to you? Write an expression that says or explains adult tickets are $3 and students are $1 and we want to know how much we're going to have.
You'd have to figure out how many adults and how many kids there are.
Okay, and so how do I do that? How do I show that in my expression or in my problem? How many adults do I have right now? Don't think about the bottom part. I have an X number of adults. Exactly right. And how much does each ticket cost for the adult?
$3.
So what do I do with X and $3? I gotta multiply them together. So remember, I can just write 3x, right? Because that's one way of showing multiplication. Now what about the kids? Are they X also? No, I gotta differentiate between kids and adults, right? So when I'm talking about kids, what do I use? Y or whatever else I wanted to, right? But how much are my Y's or my kids' tickets?
$1.
$1. So here's the question. Do I have to put a 1 in front of there? If I have a variable, any of these right here, is there anything in front of these variables right now as I wrote them up here? Everybody agrees that there isn't? What if I tell you you're all wrong? Okay? So, anytime that you have a variable and there's nothing in front of it, there's always a 1. Every single time, from here on out. And there's always a 1 right there. What do I call this little one again? It's an exponent. But there's always a 1 right there too. Unless there's some other number there. But if there's nothing there, you can always put a 1 there. You don't have to, and they don't very often, but it's always there.
You put both then, or one or the other?
You can put both every single time if you want. Yep. Yep. Now, going back to our problem though, what do I have to do with these two things? I want to multiply this and this. I want to add them together, right? Because I want to know what my total is. Okay? So now we go into, so this will work when? Anytime that we have a play and we charge $3 and $1. So if we're going to do this over and over year in, year out, we're going to use that formula right there to figure out how much we make, right? So then we go a step further. Suppose there were 70 adult tickets and 85 student tickets. How much money was collected? So we substitute what for X?
70.
And we substitute what for Y?
85.
This is where I'm just eliminating that 1 and I'm going to write my 85 down. Because 85 really is my Y. Alright? So what's 3 times 70? 210 still. Alright? 7 times 3 is 21 and I throw my 0 on there. Remember, there's ways to cheat in math to make you go faster. What's 210 plus 85?
295.
So what does this mean again? What does 295 mean?
Tickets.
The amount of money you made.
The amount of money we made, right? So at the end of every single story problem from here on out, when you get an answer, you gotta realize what that answer is telling you. Okay? It doesn't tell us how many tickets we sold, but we can figure that out. How many tickets did we sell? How many tickets did we sell total? 70 adult and 85. So how many total?
155 tickets.
155 tickets. But 155 tickets gets us $295. So again, if we're going to sell tickets, we would much rather sell what kind of tickets? Adults, right? We would want all moms and dads and grandpa and grandmas and aunts and uncles and all of them to come because we make more money off of them instead of us kids. Make sense? But again, make sure you understand what that answer is telling you. Okay? So a lot like yesterday, right? But now we're throwing in variables. So anytime it says some number, that's when I'm throwing in my variable. And again, if you're talking about giraffes, you can use G. If you're talking about kids, you can use B for boys and G for girls. You just got to be careful when you're writing some of those things. Okay? Any questions? What's tomorrow? Quiz over the first 3 sections. All right? Probably won't take you the whole period, so make sure you bring something to do after you're done. Okay? A book or something to read or something. Maybe take a nap. I don't know. All right?